Here we go, right? So yesterday or on Friday we talked about points, lines, and planes. Okay, we're just gonna do a little bit more of that today. We're looking at distance and midpoint. And then tomorrow we'll talk about segment addition, postulate, and so forth. So basically the objectives for today is very simple. Make sure you know how to use the distance formula to find the distance between 2 points. Find the midpoint between 2 points, and we're done. So lessons are really not that bad.
Let me write that down.
Where am I notes?
You guys can write down if you want. Not really that big of a deal.
To write it down.
You want to write that down?
Do we need
I wouldn't write it
It's your notes.
to do it?
That's basically what we're doing today. And that's pretty much the order in which we're going to do that.
No, I don't know.
So let's get started right away with just looking at the distance formula, thanks to the fog delay or whatever it was we had going on this morning.
ice.
I think it was
I
ice.
was really slipping my jacket.
Okay. So, in geometry, right, we'll talk about distance quite a bit. And in math class, you're constantly finding distance between 2 points. So this should not be the first time you guys are doing this. We should have definitely seen the distance formula in Algebra 1. So this, again, not really that different. What are some other terms, right? Let's say we're working on a problem in geometry. What are some of the words that we would use to represent distance? Something that would tip you off that, oh yeah, I need to do the distance formula here. Yeah, for the most obvious there. All right, we'll go with distance. So very clearly there, the distance, all right, you gotta find the distance. What are some other words that mean the same thing as distance? Length. All right,
You have very nice handwriting.
that's all right. Others? That it, just distance and length? Maybe not just words, but some phrases that mean the same thing. There we go. How far are they apart? How far is it traveled? Alright, so how far? And so those are some common words that you're going to hear in this class that indicate the length of, or the distance between 2 points. So what is actually, I mean, honestly guys, what is distance? When you hear that, what pops in your mind? Balin?
The measurement between 2 different points.
Measurement between 2 different points. All right. Okay, so tell me, how does that apply then to this diagram we have right here? How does the length AB actually relate to that? Sam?
Well, AB represents the line, and
Mhm.
the line is the distance between those 2 points.
Okay, great. Good. What shape do I have on the board right here?
Triangle.
What type of triangle? Right triangle, okay. All right, so let's keep working with that one for a minute. It's kind of an important deal. So if this is a right triangle, all right, I got my right angle right here. And this is x1, y1. Up here, you got cut off, but that'd be x2, y2. And I have a right triangle. Immediately, when you guys think of right triangle, something should be popping in your head right away. Some of you guys have seen before in middle school. I know it's going to really reinforce much since then. What is something that maybe relates to right triangles that's going to help us find the length between A and B? Balin?
Pythagorean theorem.
Yeah, Pythagorean theorem, right? We got a squared plus b squared equals c squared. And in our problem here, the length between A and B is your C, it's your hypotenuse. Okay, that's what we're trying to find. So let's have this horizontal distance right here. Let's have that be A. And this will be B.
He wants to have this triangle.
Okay. Figure it out. Now let me ask you guys a simple question. I'm going to start over here at 3. going to walk until I hit 10. How far have I traveled?
10 steps.
Nope. Where did I start? Started at 3.
Oh,
I'm now at 10. So how'd you figure that out? 10 minus 3. So you take your final minus your beginning. Does that make sense? All right, when we want to find a very simple change in distance, take your final minus your beginning, your original. Well, if we think about this as being on a horizontal line, which variable is the horizontal axis? X or Y? Which one's horizontal?
oh,
Wow. Hopefully those of you who pass algebra 1, this should be like instant. The horizontal axis is the X, the vertical is the
Y.
Y. That should not take you guys that long. Okay? Alright, so the change in my horizontal represented by A is the final minus my original, right? Well, if I'm going from A to B, my original is x1, my final is x2. So how do I find the distance between them? x2 minus x1. Now, use that same concept. How do I find the length of B? Sam?
Wait, using that same concept? So you have y, 1 minus y, no, y2 minus y1.
Y2 minus Y1. We getting this so far? That's kind of what we're doing here? Okay, what we're slowly doing here is leading you up to the distance point. So we let A be this horizontal distance, right? And that becomes x2 minus x1. So right here, what I really get then is x2 minus x1. Wow, that's really bad. Let's try that again. So I get for using the board. She's not tablet. x2 minus x1 squared, right? Because x2 minus x1 is a. Okay. So following the Pythagorean theorem, plus y2 minus y1 squared. That equals c squared. Now, do I want c or do I want c squared? I want c. So how do I get c by itself? How do I get rid of the square? Now, what cancels out a square? I don't think I heard you say it. Take the square root. We're going to get rid of that square by taking the square root of both sides. And voila, we now finally have our distance formula. So, big concept for today. This is going to be a formula you have to use over and over and over again. There you go. Make sure you know that. Okay. This would be a great time to grab a highlighter, grab your colored pencils, a gigantic box around this. Major, major, major formula for today.